absolute value functions. I guess the most basic of them all is when we simply say y equals the absolute value of the function. We've seen those ones. They're the ones where whatever's below the x-axis, we reflect above the x-axis. So it's got symmetry in the x-axis. Okay? So we reflect the part of the function x where it's negative in the x-axis. What I mean by symmetry is if you looked at the old curve and where the new curve bit. The bit you've reflected is symmetric. So here's the same random curve we looked at with reciprocal. If I was to turn this into the absolute value of function x, so it's simply anything below is reflected. So below, goodbye, goes above. And there we go. Yep. Yeah, you end up with that V sort of shape, that classic V, like the straight line absolute value curve. So it's not a turning point, it's a V. The only way it would be a turning point, it would be, so I suppose, if it was something like the cubic. If you imagine reflecting that bit above, then that probably would be a bit smoother when you reflected rather than a V. But if it's cutting through like a straight line, then when you reflect, you've got to end up with like a V shape.
So does that mean if it's a point of inflection, then only will it be a, or does that mean...
Well, horizontal point of inflection, because think of a tan curve. A tan curve's coming through at an angle. If you reflected that above, you'd still get a V there, wouldn't you? All right. Well, what about function absolute value x? Okay. This is the one that has symmetry in the y-axis. But if you look at it, we're saying, why is function absolute value x? In other words, we can never substitute in a negative number into the function. So what actually happens is the part that's on the positive side of the y-axis gets reflected over to the negative. Because whether I substitute in -2 or +2, I'm going to get the same answer. So for our random curve, that basically means anything on the left now has gone. It's now impossible to get that because I can't sub in negative numbers. But I'll get what's on the right-hand side reflected over. So that would be function absolute value of x. Okay. Now, what if we had absolute value of y is equal to function x? So what we're saying is now I can sub negative numbers in now, but my answer is always going to be positive. Because my answer, I'm going to take the absolute value of. So the absolute value of y, okay, well, I might have said that the wrong way. Let's symmetry in the x-axis with this one as well, rather than reflection in the x-axis. So what we do is we reflect the positive part in the x-axis. Let's do it via our example. There's our random one. Okay. So the bit below now disappears. Because when I substitute in x, I'm going to get the absolute value of y. I'm not going to get y. You get that. Okay? Because when I substitute in x, I'll get an answer. But then we're saying, oh, actually, it's the absolute value. So you could have plus or minus that. Okay? So I'm never going to get the negative part of the original one. All I'm going to get is all the ones that gave me positive y values. But now I could have plus or minus y. So it's reflected below as well. Okay, what about absolute value of y is equal to the function of absolute value of x? Okay, this one has symmetry in both the x and the y axes. Because now I'm never substituting a negative number into the answer. Oh, sorry, into the function. But now my answer is also absolute value. So we're going to just reflect the first quadrant. That's where everything's positive. And that's going to get reflected into all 4 quadrants. So here's my random one. It's just that piece I'm interested in. The first quadrant, and it'll get reflected in all 4. Oops, left a little bit over there, but that's okay. So that is absolute value of y is equal to the function absolute value of x. Okay, what about y equals the absolute value of function absolute value x? Okay. Well, this is where it becomes a little bit easier now, because we already know what y equals function absolute value x is. And it's like saying, do the absolute value of that curve. So it's like we combine the first two. So the first thing we draw, okay, so we've got symmetry in the y-axis, but then reflection in the x-axis after that. So the first thing we draw, remember we got that for function absolute value x. But now what we're saying is, oh, we want to draw the absolute value of that. So then we go, oh, well, whatever's below is reflected above. And we get that one. Okay, absolute value of y is equal to the absolute value of function x. So this is where I could combine the first and the third one. So we'll have symmetry in the x and also reflection in the x. Okay. So all right, there's our original one. Then we worked out that was the absolute value of function x, but now we're saying absolute, which one was I doing? Absolute value of y is equal to the absolute value. And so we have that lovely thing. Because we're saying whatever was positive, well, it was already all positive, but now we could have plus or minus for y. It'll come in there. So you can get some really interesting looking curves. All right. I think I might have left one out there, but did that cover pretty much all the possibilities? I think there might be another possibility in there, but it's a matter of combining the other ones there. So have a go at the 8E ones.